Okay, let's move to problem 5. So, Spiritual Aficionados Incorporated produces fine ashtrays, A, so that's on the y-axis, and beer steins. And the unit profit for a beer stein is $2, and the unit profit for an ashtray is $1. The production of ashtrays and beer steins requires clay and oven capacity. The total clay capacity is 11 kilogram, and one ashtray and one beer stein each require 2 kilograms of clay. The total oven capacity is 10 hours, and one ashtray consumes 1 hour of oven capacity, and one beer stein 4 hours of oven capacity. Okay, so Spiritual Aficionados needs to produce at least 2 ashtrays. So you can see I still have the template or the previous problem set open in Excel, so I think we can just work on that one again. So let's move it and create a copy. And now let's call it problem set 5. Okay, so if you want to put the ashtrays on the y-axis, so then we replace the horses by ashtrays quickly, and the beer steins go to the x-axis, and the optimum quantities, that is still something Excel will take care of. And now we have unit profits again. Unit profit, and a beer stein is 2 and an ashtray is 1. And then let's work on the constraints. So we have a clay constraint, and one ashtray requires 2, and a beer stein 2, and we have a total of 11. Then we have an oven constraint, and the oven constraint is an ashtray requires 1 hour and a beer stein 4 hours, and we have a total of 10. And then we have a demand constraint. We have to produce at least 2 ashtrays, so I put under ashtrays a 1, but a 0 under beer stein, and the sign has to be greater than or equal, and so at least 2. Okay. Okay, so we have to change that a little bit. So let's call the constraints clay, oven, demand. Okay, so the clay constraint is equal to, and by now we already know the formula. So yeah, let's also change before we continue with the formulas. Let's also change quickly the axes. So here we have the ashtrays, and on the x-axis we have the beer steins. Okay, so for the clay constraint, we know that if we use up all our clay to produce ashtrays, then we can get 5.5. And what we enter, the formula is equals to the maximum of clay, F4, divided by the ashtray coefficient minus the Bierstein coefficient divided by the ashtray coefficient times the number of Biersteins. And I still have to replace here. The x-axis is now the Biersteins. And again, I want to avoid negative values. And in order to replicate the graph that you see in the problem set, what I quickly will do is I will also limit the x-axis to 10, and what I will do is I will just add a step value of 0.5. So we go to Home, Edit, Fill, Series, and what I will do is I just add a 0.5 and then I should end at 10. Okay. And again, I want to avoid those negative numbers. So I put an if command around. If this is less than 0, then enter number not available, but otherwise use this formula. And then, so now we shouldn't see any negative numbers. Good. And is it in the graph already? Yeah, we'll fix that later. So now we have the clay constraint. And by the way, that's less than or equal. Less than or equal. So now the oven constraint is equal to the maximum amount available oven capacity divided by the coefficient for the oven, which is 1, then minus the Bierstein coefficient divided by the oven coefficient, the ashtray coefficient times the number of Biersteins. And again, let's avoid negative values. If this equation evaluates to less than 1, then number is none available. Otherwise, use this formula. Okay. And for the demand constraint, we have at least 2 ashtrays. So that means we need a vertical line at 2, and so that is simply equal. So because now I need a vertical line here at 2, I'll just say this is always equal to the limit of the minimum demand. So I just say F4, and I just copy that down. Okay, so now we should have where's that 6 coming from? And okay, so the area of feasible production, it says 666. We have to change that again to min. And actually, we don't need the area feasible production. It's always a little bit difficult to draw in Excel if you have if you have different constraints, like a minimum constraint of this and a maximum of this. So let's just forget about that one. And now we have again an ISO profit line. Okay. So yeah, it's oh, there's something wrong with the oven constraint. So let's see what went wrong here. So we do if G7 divided by C7, that's correct, minus D7, that's correct, over C7, so it's a slope of -2, times B11 is less than, so that's correct. Oh, I forgot here, at the end, times the 0, okay, so now it should look nice. Okay, so now it starts making sense. Okay, so let's change that quickly to a change the chart type. It is a combo, so the clay constraint is a line, and the oven constraint is a line, so they're all lines. Okay. And then let's make sure that the values are not between the tick marks, but on the tick marks. And the last thing I do is I change the axis type. I put it at a maximum of 10. Okay. And what else can I do? Maybe I can say major units. What happens if I put here 2? Need 1.5. Okay, so then we can see the values in between. So we can see the decimals. If you don't like that, we can remove that and work maybe on the tick marks and the labels. So if you want to change this graph from an axis and so the major units is 0.5, display, tick marks, labels, number. So let's go back to 1 and then we change the tick marks. To maybe the grid lines minor, okay. So now we have here minor 0.2. So we want to change the minor tick marks not to 0.2 but to 0.5, and then it should look nice. So 0.5. Okay, so that's it. Okay, so this is our function, and let's also draw it now into the problem set here to the left. And again, the total clay capacity is 11, and each one needs 2 kilograms of clay. So we get the 5.5 to the 5.5. So insert. So what I do is I'll just quickly insert a line that goes from 5.5 to 5.5, and okay, make it orange too so it matches the Excel, make it a little bit bigger. Then the oven constraint, which is here blue, insert, shapes, and then a line that goes from 10 to 2.5. So format shape, let's make it a little bit bigger too. And the last one is the minimum demand for the ashtrays. So insert, shapes, line to 2. And outline weight, and let's make that maybe also some green. Okay, so that's it. So the area of feasible production is now everything above the green and below the orange and to the left of the blue. So now we still need to add the ISO profit line. And you know that the ISO profit line is given by, so we always write total profit is equal to the unit profit of the ashtray times the amount of ashtrays plus the unit profit of the beer stein times the amount of beer steins. Then we have to rearrange this, so we have A to the left side of the equal sign. So then we get unit profit A times A equals total profit minus unit profit beer stein times beer stein. And then we divide by the profit for the ashtray. And then our ISO profit line becomes total profit divided unit profit ashtray minus, and that's the important part now, because the slope, that is what we want, it's the unit profit of the beer stein to the unit profit of the ashtray times the number of beer steins. Okay, what we are interested in is really this part here. So what we know is that the ratio of the unit profit of beer steins to ashtrays, it's -2. So we can insert here to the left the ISO profit line with a slope of -2. So I draw something that goes from 6 to 3, that's -2. And that is basically the arbitrary ISO profit line. Maybe I'll make it black and increase the weight and maybe dash it. And then what we need to do is we want to maximize profit. We want to shift that as far out as we can. And now you can see, actually we can see it better if I make it a little bit smaller. Okay, so you see that we have now a solution where the optimum is presumably 4 ashtrays and 1.5 beer steins, but we cannot do we cannot sell half a beer stein as it won't hold any beer. Okay, so let's do the same thing also quickly in Excel. So let's rewrite the ISO profit line. So the ISO profit line is the total profit, which we pick up from the Excel solver solution. Then we divide by the unit profit of ashtray, so that's and then F4 minus the ratio of the unit profit of the beer steins to the unit profit of the ashtrays times 0. And we copy this down, and you see now we get all those negative values. We don't really want negative values. So what we do is we say again, if this equation gives a value of less than 0, then enter number not available. Otherwise, we use this formula. And then we copy down that formula. Let's see if I made a mistake here. Okay, so it's okay. So now let's see what we get in Excel. So we go to Data, Solver. Okay, yeah, this is my maximum profit. I just reset all. Okay, so my maximum profit is in cell E3 by changing those two cells. And my constraints are the first two are less than or equal. So I can combine the first two by dragging and dropping those cells. Now we add the final one where the total usage, the demand, has to be greater than or equal to the 2. Okay. And so that's it. So now we say, okay, keep the solver solution. And you see we have here exactly the same problem that we derived manually. So now the question becomes, if you use an integer solution, because you can sell half a beer stein, what is the next best integer solution? So we take our arbitrary ISO profit line and we see what is the next best integer solution. So shall we produce maybe 4 and 1? And if you look carefully, that is actually the same as 2 and 2. So you see that is a 4 and 1. This seems to be the same ISO profit line as 2 and 2. So we can't realize this, so but the next nearest integer solution is 4 and 1. But it also would work with 2 and 2. So let's just see if that's correct. Then we just play around quickly here by saying 4 and 1. That gives us a profit of 6. And what about 2 and 2? Well, that gives us a profit of 6 too. So technically here we would have 2 solutions. And well, let's actually see what Excel gives us. Excel probably will choose 1. And so let's see what we get if we initialize everything with 0, 0. Okay. And we solve it. Okay. So Excel gives us 4 and 1.5 because I haven't added yet the integer constraint. Okay, let's go back to 0, 0. And what we do is we add now the constraint that the optimum quantities are supposed to be integers. Okay. Okay, so we know that we have two solutions, 4 and 1 and 2 and 2. So let's see what Excel presents us. 4 and 1. Okay, that's interesting. I don't know what Excel does. It's probably the first solution that it found. What would happen if we initialize it maybe with 10 and 10? So will it be also 4 and 1? I don't know. Just curious now. Yeah, so for whatever reason, Excel prefers 4 and 1. But theoretically, we would have two solutions. Okay, so now let's quickly browse through the questions here. Which formula describes the clay constraint? So that's the orange one, and that's 5.5 minus 1. Which formula describes the oven constraint? That's the 10 minus 4, B. Which formula describes the demand constraint? That's ashtrays has to be greater than or equal to 2, so that's C. Which statement is true? The line of feasible production is an area below all constraints? No. Above all constraints? No. Below the clay and oven constraint and above the demand constraint? That's correct. The ISO profit line has a slope of -2. The optimum solution consists of how many ashtrays? Well, per Excel it would be 4. The optimum solution consists of how many beer steins? 1. And you see I didn't give you here the option for 2 and 2, but remember that would be a solution as well. Okay. Oh, that question actually was still without. So the optimum solution first was 4 ashtrays and 1.5. So the question here is actually 1.5. So, because now the question is what about the integer solution? So now assume that the optimum solutions must be integers. Then the optimum solution consists of how many ashtrays? Well, that's still 4. And then the optimum solution consists of how many beer steins? So that's 1. And in Excel, the command for enforcing integer solutions is integers. Okay, so that's the problem set to integer solutions. And yeah, we have one more left, and that is about 0-1 programming, but let's do that in a separate video. And let's just stop here, and I'll see you in the next one.